Good morning, students. In this video, that is video number 3, we will discuss the topic equilibrium of bodies. So far, we have studied that when a single force acts on a body, it can produce translational motion if the body is free to move, or can produce rotational motion if the body is fixed at a point. So, whenever a number of forces acting on a body, like this body, let this body is there, and the number of forces is acting on it. These are the forces. So when a number of forces acting on a body produce no change in its state of rest or of linear or rotational motion, the body is said to be in equilibrium. So kinds of equilibrium. Kinds of equilibrium. There are two types of equilibrium. One is static equilibrium. Another is dynamic equilibrium. Dynamic equilibrium. So, static and dynamic equilibrium. So, what is static equilibrium? When a body remains, let this body is in rest. Let this body is in rest. When a body remains in the state of rest, under the influence of several forces, the body is in state of equilibrium. Clear? The body is in state of equilibrium. So, next is dynamic equilibrium. Let this body is in motion, rotational motion or linear motion. And when a body remains in the same state of motion, that is linear or rotational, under the influence of the several forces, the body is said to be in dynamic equilibrium. Static means in rest, dynamic means in motion. Clear? Even we have discussed one examples like a raindrop. It falls with a constant velocity on the surface of the earth. Now the weight of this, weight means mg. The weight of the drops, it acts vertically downward direction. Now the weight of this falling drops is balanced by the sum of two forces, that is force of buoyancy, and the frictional force. So when the weight of the raindrop is balanced by these two forces, this is a force of buoyancy and this is a friction or viscosity. So the net force acting on the drops, that is 0. So it falls with a constant velocity, and the motion of the falling drops is a dynamic equilibrium. Now condition for equilibrium that is the resultant of all the forces acting on the body should be 0. Like this, 0. It is acting vertically downward direction, it is acting in opposite direction. So these are equal and opposite, they will cancel each others. So the resultant of all the forces acting on the body should be 0. This is the first condition. Then the algebraic sum of moments of all the forces acting on the body about the point of rotation should be 0. मान के चलते हैं कि this is the point of rotation. ठीक है? The algebraic sum of the moments of all the forces, these forces which are acting on it about the point of rotation should be 0. So these are the two condition for equilibrium. So far we have studied the principle of moments. Now, according to principle of moments, that is sum of anti-clockwise moments, that is equal to sum of clockwise moments. Sum of clockwise moments. This is the principle of moment. This we have already studied. Sum of anti-clockwise moments, that is equal to sum of clockwise moments. Now, verification of this law. Verification of this law. First of all, let this is a uniform meter rule. Clear? This is a uniform meter rule, and this is the center of gravity or center of mass of this lie here. Now, let at this point the weight W1 is suspended, and at this point let the weight W2 is suspended. Now students, just see to it. Let this point is A, this is O, this is B. Now the distance between A and O, let that is L1, and O and B, that is L2. So in which direction this will move or show its moments? It depends. The C2 from here to here and from here to here. Here the perpendicular distance is more and here the perpendicular distance is less. So the moments will be like this. Clear? ये ऐसे और ये ऐसे. So sum of, according to the principle, sum of anti-clockwise moments you can take from here. क्या हो जाएगा? That is W2 into L2. This is equal to W1 into L1. So in equilibrium, when this uniform meter scale be in equilibrium or in horizontal position, It means that W2 into L2, that will be equal to W1 into L1, or the anti-clockwise moments, that is equal to clockwise moments. So that's all in this video. Thank you very much.